Hello everybody. This is our last shot at the FTC. It's such an important theorem in AP Calculus. And this is the last type of problem that we'll see. It's very popular in AP Calculus and it's also very, very popular on the AP exam. We see this type of problem a lot, but it's really easy once you got the steps down. So I'm just going to remind you. If you saw on the module, in the work module, we talked about the idea of if you ever see a problem where you have the antiderivative and you're given one value, and you're asked to find another value. Just like you saw in the picture, you're going to basically set up an integral and rewrite it using the antiderivative. All right, so we're given g of 2 is -7, and we're told that g is the antiderivative. So here's what that really means. If I put that together with our diagram, that means I can write this. That means if g is an antiderivative of f, okay, that means if g is the antiderivative of f, and we usually write the t on the inside in order to get an antiderivative of x. Let's see, and what numbers did they give us? They gave us 2, and we're looking for at 4. So that means we can take those 2 and the 4 and put them here on your integral. There's 2, and there's 4. All right, by FTC part 1, when I take the antiderivative of f, I should get g back out. But because it's a definite integral, I should literally get, well, the antiderivative of f of t should be capital G, but evaluate at 4 minus capital G antiderivative, evaluate at 2, right? That's how we do definite integrals. Well, let's see. They say that g is an antiderivative of f of x. And g of 2 is -7, and g of 4 we don't know. So g of 4, I'm going to isolate him because I don't know what he is. But it says over here that g of 2 is -7. Okay, that means if I rewrite everything here, I can say the integral from 2 to 4 of f of t dt should be the antiderivative evaluated from 4 to 2, meaning the integral of 2 to 4 of f of t dt equals g of 4 I don't know, I'm going to search for that, minus g of 2 is -7. That negative just turns into a positive. So what is g of 4? One more step. G of 4 should be equal to, let's see if I bring that over, I have to subtract it. So how about -7 plus the integral from 2 to 4 of f of t dt. Let's see if we can find that answer somewhere in my multiple choice here. Yep, did you see it? And that's it. There are several problems like this on the AP exam and in our class, but again, to recap, here's what you did. You're given an antiderivative, or sometimes maybe you have to find it, but you're given one value of the antiderivative, and you need to find another value of the antiderivative. When that happens, you set up the integral using the values they gave you, using the evaluation theorem from FTC, and you solve for the value you don't have. All right, on this worksheet, there are 3 more problems that I would love for you to try. So go ahead and pause the video. Can you try those 3? And then when you're ready to check them, let me know and we'll go over them together. All right, folks, let's see how we did. So reading this first problem up here, question number 1, particle moves along the x-axis. So we're in particle motion, 2-dimensional. So it's probably moving left and right because it's on the x-axis. Acceleration is given by, here's acceleration. If the velocity, okay, stop. Right now, velocity is the antiderivative of acceleration. Right? Because the derivative of velocity should give you acceleration. So right now we're given acceleration, or we're given the formula for acceleration, and we know the velocity, we know the antiderivative, the velocity is equal to 2 at time equals 1. That's the value they give you. What is the velocity at time equals 2? So they give us one value, you need to find the other value. So you know by FTC we're going to set up an integral. Now look at the answers and you can tell this is definitely going to be a calculator type problem. Alright, so here's the calculator problem that we're going to set up. We know that we said over here the antiderivative of acceleration is velocity. So let's set this up. The antiderivative of the acceleration function, now what values did they give us? They gave us time equals 2 and time equals 1. So I'll put 1 and 2 on my integral. That should be equal to the antiderivative acceleration's velocity evaluated at 2 minus the velocity evaluated at 1. Now we know that the acceleration function is this up here, so I can plug this in and try to find the integral from 1 to 2 of this function. We can't do this by hand, so we're going to plug this into a calculator using Math 9. Remember that? And then, do we know what velocity at 2 is equal to? No, that's what it's asking for. But we do know what velocity at 1 is equal to, and we'll plug that in. All right. So when I plug this into the calculator on the left side, I'm going to use Math 9. I'm doing the integral from 1 up to 2. The acceleration function is the ln button of 1 plus 2 raised to the t, and we can just put x for t. ln of that with respect to x. I plug that in. The calculator tells me that just this left part is equal to 1.346, 3 decimal places. On the right side, that should be equal to v of 2, which we're solving for, minus what was v of 1? Up here they said v of 1 was equal to 2. So now let me just solve for v of 2. Over here, v of 2 equals 1.346 plus 2, 3.346. Let's see if we can find that answer amongst our choices. And there it is. The answer for number 1 is E. If you feel like you're getting the hang of it, go ahead and take a pause, try the next two, and I'll come back in a minute to help you out. All right, let's take a look at the next one, folks. Number 2 here. Let f of x be the antiderivative, and I'm given an antiderivative value, and I need to find the other antiderivative value. There you go, FTC. Let's make an integral. So f is the antiderivative of ln of x cubed over x. That sounds good. Let's look at the values that we're trying to plug in here. They tell us that the value at 1, okay, I'll put a 1 down here on the bottom of the integral, and at 9, so I'll put 9 on top. Okay, let me write this in a really absolute correct way. The integral from 1 to 9 of the ln of t cubed over t dt equals, well, the antiderivative of this function we said was f, capital F. F is the antiderivative. This should be equal to f of 9 minus f of 1. All right, if you look up at the given values, f of 1 is equal to 0. So I can just basically cross that off, and I'm solving for f of 9. Well, this is really nice, because f of 9 is just this left-hand side. Look at your answers. I'm thinking calculator. So go ahead and plug this in, Math 9, the integral from 1 up to 9 of the ln of x quantity, careful as you plug it in, cubed, divided by x. With respect to x. And I get about 5.827. Let's check and see if it's there. And there it is. Answer for this one's C. How are we doing? 2 for 2? Let's do the last one. Number 3. F is the antiderivative. I'm given one antiderivative value. I need to find the other one. And here's our function. I think this is an x squared on top. It's a little bit hard to see. Look at the answers. I'm thinking calculator. So we know that f is the antiderivative of x squared over 1 plus x to the 5th. Let's look at the values they give us. Plug that into my integral. So here we go. That opening stuff is basically just scratch work for my head, but here's where I officially write everything out. The integral from 1 to 4 of, oh, I put x. It's not a bad thing if you put x, but I just want to be consistent with the letters using FTC. T squared over 1 plus t to the 5th dt. If f is the antiderivative, that should be f of minus f of Once again, you see that f of 1 is equal to 0, so I can just plug in 0, and I'm just solving for f of 4. We said we're in calculator mode, so let's just plug the whole left side into the calculator, and this, using Math 9 again, the integral from 1 up to 4 of x squared divided by 1 plus x raised to the 5th. I have a lot of parentheses here, folks, to help me out. Dx. I plug it in. So f of 4 should be equal to 0.37566, so 3.7376. Let's see if that's my answer. And there it is. And I do remember that these are the two answers, guys. So there you go. That's the last type of problem we see with FTC. It's really important because we do see it so many different times in the AP. Good job.